Welcome back to Sunain Sir's online classes. In this video, I am going to explain you some interesting topics. I request you to watch this video till the end. First, I would like to explain you specific heat. Specific heat is nothing but amount of heat required to increase the temperature of unit mass of a substance through 1 degree centigrade. For example, I have a water in a tub and I am going to use this water to take bath. So first I am going to heat this water by putting it on a stove. So when I am heating this water, initially if this water is at a temperature of 25 degrees centigrade. Now when I am heating this water, its temperature increases from 25 to 30, 35, 40 and so on. So when I am supplying heat energy to this water, its temperature is going on increasing. Now in order to increase the temperature of the water from 25 degrees centigrade to 26 degrees centigrade, how much heat energy I am supplying? That heat energy is nothing but specific heat. So specific heat is nothing but amount of heat energy we are supplying to increase the temperature of water through 1 degree centigrade. Through 1 degree centigrade, if you are heating the substance, for example say 25 to 26 degrees centigrade, you are heating the water. So in order to heat from 25 to 26, whatever the heat energy you supplied, that heat energy is nothing but specific heat. So finally specific heat is defined as amount of heat energy required to increase the temperature of unit mass of a substance through 1 degree centigrade. And derivation of this specific heat. See, we know that heat energy supplied is directly proportional to mass of the substance. If you are heating less quantity of water, say if you are heating water in a small mug, then heat energy needed to heat that water is very less. Whereas if you are heating the water in a very large tub, heat energy required to heat that water is more. You need to heat to a large extent. Large amount of heat energy is needed. It means heat energy is directly proportional to mass of the substance, and heat energy is directly proportional to temperature change delta T. It means if you want to heat water to very high temperature, it means if water is initially at 25 degrees centigrade, if you want to heat it to only 30 degrees centigrade, then less amount of heat energy is required because temperature change here is less, that is only 5 degrees centigrade. Whereas if you want to heat water from 25 to 50 degrees centigrade, you need to supply more amount of heat energy because temperature change is more here, that is 25 degrees centigrade is the temperature change. So heat energy is directly proportional to temperature change delta T. So from this we can say that heat energy is directly proportional to m into delta T. And if we remove proportionality symbol, we will get one proportionality constant. That proportionality constant is nothing but specific heat S. S is nothing but proportionality constant, and that is nothing but specific heat S. So S is given by S is equal to Q by M delta T. S is equal to Q by M delta T. So this is the derivation for specific heat. So heat energy is directly proportional to mass, and heat energy is directly proportional to temperature change. So Q is equal to ms delta T and S is equal to Q by M delta T. Now let us see what are the units of specific heat. So we know that units always will come from the formula. So formula for specific heat is Q by M delta T. So in SI units, in SI units, sorry, this is the unit of SI, system of international units, are joule per kg Kelvin. So in SI units, unit for energy or heat energy is joule by, unit for mass is kg, and unit for temperature is Kelvin. So SI unit of specific heat is joule per kg Kelvin. Whereas for CGS unit, unit of heat energy is calories, and unit of mass is grams, and unit of temperature change is degree centigrade. So this is the CGS unit. And we have one conversion factor, that is, in order to convert from SI unit to CGS unit, everywhere if you take SI unit will be, generally SI unit will be greater than CGS unit. Example is, SI units of length is meter and CGS unit of length is centimeter, and if you take 1 meter is equal to 100 centimeters. It means generally everywhere SI unit will be greater than CGS unit, that is 1 meter is equal to 100 centimeters, for example. But here in case of heat energy, CGS unit is greater than SI unit. Remember, in case of heat energy, CGS unit is greater than SI unit, and 1 CGS unit of heat energy, that is 1 calorie per gram degree centigrade, is equal to 4.18 into 10 power 3. 4.18 into 10 power 3 joule per kg Kelvin. This is very important. I request you to remember this conversion from CGS to SI. Next, let us see properties of specific heat. First one is, specific heat is constant for one substance and it varies from substance to substance. It means for one substance, if you take example water, for water specific heat is constant and its value is 1 calorie per gram degree centigrade. It means if you take water anywhere, if you take water at 25 degrees centigrade, or if you take water at 35, or if you take water at 45, or if you take water here, if you take water in other country, or if you take water in other continent, wherever you take water, for water specific heat value will remain same. It is always constant. It will remain same. And from substance to substance it varies. It means for water its value is 1, whereas for ice its value is 0.5. Some lead, for some lead its value is some other, and for other substance its value is some other. It means for substance to substance specific heat will be changing, and for one substance specific heat will be always constant. And second one is, specific heat represents the heat storage capacity of a material. Specific heat always represents heat storage capacity of a material. It means if specific heat is more, then substance can store large amount of heat without much increase in temperature. It means, for example, if you take water, for water specific heat is highest. That is why whatever the heat energy if you give, if water is initially at 25 degrees centigrade, if you supply 100 calories of heat, then its temperature will be some 30 only. Whereas if you take some other substance, whose specific heat value is low, say for example lead, and if initially if lead is at 25 degrees centigrade, and if you supply same 100 calories of heat, then its temperature will go on to some around 50 degrees centigrade. It means if specific heat is high, then that substance will store large amount of heat energy without much increase in temperature. If specific heat is let, for small amount of heat energy if you supply also, that substance it will increase its temperature to a greater extent. So specific heat is highest for water, and hence it is always used as a coolant. It can absorb large amount of heat energy with less change in temperature, delta T, it can absorb large amount of heat energy. That is why in all automobiles water is used as a coolant. And for water, specific heat value is 1 calorie per gram degree centigrade, and specific heat is least for lead, and specific heat of ice value is 0.5 calorie per gram degree centigrade. You need to remember specific heat of water value and specific heat of ice value. Now let us see what is internal energy. Internal energy is nothing but total energy contained in a system is called internal energy. It means whatever the energy present in the system, total energy, it means system will have so many energies like potential energy, kinetic energy, pressure energy. Sum of all these energies whatever present in the system is called internal energy. Internal energy is nothing but sum of all energies present in a system, that is total energy present in a system is called internal energy. Now why specific heat is different for different substance? Why specific heat should be different for different substance? It means why it is highest for water and why is it least for lead and why is it 0.5 for ice? Why specific heat is different for different substance? Let us see why. So when heat energy is supplied to the substance, this heat energy is utilized to increase the temperature of substance in different forms depending on the substance. Whenever heat energy is supplied to the substance, this heat energy will be utilized to increase the energy of substance in different forms depending on the substance. Some substance will utilize this energy to increase internal energy, whereas some substance will utilize this energy to increase potential energy, and some will utilize to increase kinetic energy. So whenever you supply heat energy, different substance will utilize it in different forms. The substance which utilizes this heat energy to increase linear kinetic energy, for that substance specific heat will be high. For remaining substance specific heat will be low. So finally, the substance which utilizes the heat energy to increase linear kinetic energy, that substance will have higher specific heat, and other substance which utilizes this heat energy to increase potential energy. If any other substance utilizes this energy to increase rotational kinetic energy, or if any other substance utilizes this energy to increase vibrational kinetic energy, for those kind of substances specific heat will be low. So for the substance which utilizes heat energy to increase linear kinetic energy, for that substance specific heat will be high, and for remaining substance it will be low. Hence specific heat is different for different substances. And now let us see very important question, textual question, applications of specific heat. Applications of specific heat. Every day we know that sun delivers large amount of heat energy to the earth. This heat energy will be absorbed by water bodies present on the earth like seas and oceans. Mostly 3/4 of the earth is covered with water, that is covered with seas, oceans, rivers, lakes, ponds, etc. So this heat energy whichever it is delivered by the sun, that is absorbed by water bodies like seas and oceans. They will act as storehouses of heat energy. They will absorb all this heat energy without much increase in temperature due to high specific heat. Previously I explained you water will have high specific heat. It can absorb more amount of heat energy with less change in temperature. That is why these all the heat energy whichever it is supplied by the sun, whichever it is delivered by the sun, that heat energy is absorbed by seas and oceans, and without less without much change in temperature, or with less change in temperature. It means if ocean is at a temperature 35 degrees centigrade initially during daytime, so when it is absorbed all the heat energy delivered by the sun, its temperature will be nearly 36 only. It means there will be very less change in the temperature of the ocean or sea. If ocean or sea is not made up of water, if it is made up of with any other substance like lead, then its temperature would have gone to 50 degrees centigrade, because lead will have least specific heat. That is why, since oceans are made up of water, they are absorbing large amount of heat energy and they are maintaining the temperature of the earth as constant. If it is made up of some other substance like lead, then temperature would not remain constant, it will go up to 50 degrees centigrade, which is very dangerous to our humans. In this way, here you can see in this image, oceans and seas, they are absorbing large amount of heat energy, still they are remaining cool only, still they are remaining at 35 degrees centigrade only, they are remaining cool, and they will transport all this heat energy whichever it is delivered by the sun. They will transport all this heat energy away from the equator to the north and south poles. In this way, oceans and seas helps to maintain constant temperature of the earth. And one more example for application of specific heat is watermelon brought out from a refrigerator retains its coolness for long period of time because it contains large percentage of water, and water has highest specific heat. It will store all the heat energy for long period of time, because mostly watermelon is made up of water. And one more example is samosa. Samosa appears to be cool outside, whereas if you take a bite, inside it will be hot, because whatever the ingredients present inside the samosa will have higher specific heat. Hence, inside ingredients will store that heat energy for long period of time because of higher specific heat. Next, let us see latent heat. What is latent heat? For example, if you have water at 25 degrees centigrade, if you have water at 25 degrees centigrade and you started heating this water by putting it on a furnace. Now when you are heating this water, it means when you are supplying heat energy, its temperature will go on increasing from 25 to 35, 45, 50, 55, 65, 70, 80, 90 and 100. So when you are supplying heat energy, initially the heat energy whichever you are supplying is utilized to increase the kinetic energy of the molecules. Whatever heat energy you supplied, that heat energy is utilized to increase the kinetic energy of the molecules till 100 degrees centigrade. So after 100 degrees centigrade, what happens is, here you are reaching the boiling point of the water. So whenever you are reaching the boiling point of the water, then this heat energy whichever you are supplied is utilized to break the bonds between the molecules. As water molecules will be nearer to each other, they will have large number of attraction forces. So at 100 degrees centigrade, whatever the heat energy you supplied is not utilized to increase the kinetic energy, and it is not utilized to increase the temperature of the substance, whereas it is utilized to break the bonds between the molecules and to break the attractive forces between the molecules. Hence, as a result, all the molecules will go away apart from each other, and all the attractive forces between the molecules are broken, and hence liquid molecules will be converted into vapor molecules, and temperature will remain constant only till 100 degrees, at 100 degrees centigrade, till all the liquid is converted into vapor. Temperature will remain constant, that is it will remain 100 degrees centigrade only, because whatever the heat energy you are supplying is utilized to break the bonds between the molecules. Hence temperature will remain constant, and once all the bonds are break, and once all the liquid molecules are converted into vapor molecules, then temperature will start increasing from 100, it will go to 101, 102, 103, 104. So till all the liquid is converted into vapor, so its temperature will remain constant only. At 100, it means at 100 degrees centigrade, at 100 degrees centigrade, it means at boiling point of water, whatever the heat energy you are supplying is utilized to break the bonds between the molecules. It means it is utilized to change the phase of a substance. So the heat energy whichever you are given to change the phase of a substance is called latent heat. Latent heat is nothing but heat energy required to change the phase of a substance from one state to another state. That is nothing but latent heat. Latent heat is amount of heat required to change the phase of a substance of unit mass at constant temperature and pressure. And this heat energy is directly proportional to mass, and it is Q is equal to ml. Latent heat is equal to Q is equal to ml, whereas L is the latent heat constant and L is given by Q by m. Amount of heat required to change the unit mass of a substance from one state to another state at constant temperature and pressure. So units are, we'll get units from the formula. Cgs units are calorie per gram, whereas SI units joule per kg. Latent heat of fusion of ice is 80 calories per gram. It means in order to convert 1 gram of ice to 1 gram of water, then you need to supply 80 calories of heat energy. And latent heat of vaporization is 540 calories per gram. It means if you want to convert 1 gram of water into 1 gram of vapor, you need to supply 540 calories of heat energy. Now let us see some interesting points. First one is zeroth law of thermodynamics. Zeroth law of thermodynamics. Zeroth law is the basis for temperature measurement, and it says that if two objects, let us say A and B, if two objects A and B, if they are in thermal equilibrium with another object C individually, it means if A is in thermal equilibrium with C and if B is in thermal equilibrium with C, then A and B will be in thermal equilibrium with each other. A and B will be in thermal equilibrium with each other. If two objects A and B are in thermal equilibrium with another object C individually, then A and B will be in thermal equilibrium with each other. It means simply you can say if A is equal to C and if B is equal to C, then simply A is equal to B. It means if A is in thermal equilibrium with C and B is in thermal equilibrium with C individually, then A and B will be in thermal equilibrium with each other. That is what zeroth law says. It says that if two objects A and B are in thermal equilibrium with another object, third object C individually, then A and B will be in thermal equilibrium with each other. This is zeroth law of thermodynamics, and it is the basis for temperature measurement. Now, I think most of you have observed that when we keep glass bottle which is completely filled with water in a deep freezer, and after 2 or 3 hours if you see this glass bottle will break, it will undergo cracks in this way. If you fill glass bottle completely with water and if you keep it in a deep freezer and if you take it outside after 2 or 3 hours, it will undergo cracks or it will break in this way. The reason for this is now we are going to see that. Generally, any substance when heated it will expand. It means its size will increase, and when you cool it, when it is cooled, it will contract. It means its size decreases. This is general fact, we all know. But water is a special case to this. It has a peculiar property of expanding on freezing. It means when you decrease the temperature of water, when you freeze the water, its size increases. Its size increases. It will expand. Water expands on freezing. This is fact which is very interesting one. This is the reason for breaking of glass bottle when it is completely filled with water and in kept in deep freezer. Because when you fill the water completely, when you fill the glass bottle with water completely without any gap, in the glass bottle, if you fill it completely and if you keep it in deep freezer, then when water's temperature is decreasing, its size will increase, it will expand, its size will increase. Whereas, but there is no gap in this glass bottle, no gap in this glass bottle to allow the expansion of water. For this reason, this water on expanding, it will try to expand, and since there is no gap, it will apply lot of pressure on the glass bottle, and as a result glass bottle will break. This is the reason for breaking of glass bottle. Next important and interesting topic is ice floats on water. I think most of you have seen in English movies that ice is floating in the middle of the sea. In the middle of the sea, in English movies, most of you have seen, and also in Titanic movie also they will show that ice is floating in the middle of the sea or ocean. Or if you pour some of the ice cubes in a glass of water, they will float on the top of the water, as you can see in this image. It means ice floats on the water. We know that generally solid objects will sink in water like steel, aluminum, etc. But there are some objects, some substance which float on water like wood. Similarly, ice is also such type of substance which floats on water. For any substance to float on water, density of substance should be less than density of water. So similarly, since ice is floating on water, density of ice is less than density of water, and density of water is 1 gram per cc, whereas density of ice is 0.925 gram per cc. So density of ice is less than density of the water, since it is floating on the water. And we can feel everyone high sultriness in summer. Everyone, we can feel high sultriness in summer. First of all, what is this sultriness? Sultriness is nothing but irritation because of sweating. Irritation caused because of over sweating, high sweating. In summer season, if you have done any work, in summer season if you do any work and if you sweat after doing work, this sweat will remain on your skin for long period of time without getting evaporated. That is because of this reason you will get lot of irritation on your skin, and that irritation is nothing but sultriness. This high sultriness is caused especially in summer season, and the reason behind this is high humidity in air. Because of presence of high humidity in air, it means because of presence of high amount of water vapor in air. We all know that air will have higher affinity towards water vapor. It means wherever air sees water vapor, wherever air sees water and wherever air flows through water, it will try to absorb that water and it will get mixed in the air in the form of water vapor. This is nothing but because of higher affinity of air towards water vapor. So wherever it sees the water, it means wherever it flows through the water, for example through seas and oceans, it will try to absorb that water from the surface of the seas and oceans, and it will convert that water into vapor, and this vapor get mixed with the air. In summer season, because of high rate of evaporation, humidity present in the air will be high, that is nearly 80 to 90%. And because of this high humidity, and air will be completely saturated with the water vapor, it will not try to absorb water vapor anymore. It will not try to absorb water vapor anymore. As a result, when air flows through our body, which is full of sweat after doing work, air will not absorb sweat from our skin, and this sweat will get deposited on our skin, and this causes irritation, which is nothing but sultriness. Whereas in winter season, if we get sweat also, because humidity in the air will be very less, that is nearly 20 to 30%, whenever air flows through our skin, it will try to absorb that sweat through our skin, and we will feel comfort. And during summer season, when air flows through our skin, as air will have less humidity, that is nearly 20%, it will try to absorb water which is present in our skin, from our face and from our lips, and as a result our face and our lips will get cracks. In this image you can see this person is getting lot of sweat and sultriness after doing a jogging in summer. Thank you for watching the video.